Welcome to the lesson on Introduction to Euclid's Geometry. At the end of this lesson, you will be able to list and define Euclid's definitions, axioms, and postulates. Euclid began his treatise by defining the concept of a point. Look at this point. Can we see this point on the screen? Actually not. Let's magnify it so that we will be able to see the point. Oh yes, now we can see the point. The first definition says that a point is that which has no part. By no part, Euclid meant that a point does not occupy any area in space. In other words, we can say that a point does not have any dimensions. The second definition is about the concept of a line. A line is a breadthless length. Generally speaking, breadthless means that the width of the line is negligible. In other words, the line has only one dimension, which is its length. The third definition is, the ends of a line are points. Here Euclid talks about a line segment. A line segment has two ends, which in turn are points. The fourth definition says that a straight line is a line which lies evenly with the points on itself. Let's try to understand what this means. Although accurate interpretation is not possible, it can be imagined that a straight line is formed by a collection of points which lies evenly along the straight line. The fifth definition states that a surface is that which has length and breadth only. It's clear that the length and breadth account for two dimensions similar to the x and y axes. The sixth definition states that the edges of a surface are lines. This is an extension of the third definition, which says that the ends of a line are points. The following example will help us understand the sixth definition better. Let's consider a circular metal disc which has a negligible thickness. This disc resembles a circular surface. If we consider its edge, it resembles a circle. So far we have seen what Euclid said about points and lines. Now let's see what he says about a surface. The seventh definition states that a plane surface is a surface which lies evenly with the straight lines on itself. To understand this definition better, let us recall the idea of the fourth definition. A line lies evenly with the points on it. Similarly, we can understand that a plane surface is formed by evenly spaced lines which are very close to each other. Thus we have seen the 7 definitions proposed by Euclid. With these definitions, Euclid tried to describe the fundamental elements of geometry. To conclude, he tried to explain about the concept of dimensions and the elements associated with it, like a point has no dimension, a line has one dimension, and a surface has two dimensions. Now that we have understood the definitions, we come to the next level of Euclid's geometry, the postulates. Postulates are statements which do not require any proof, are self-evident, and deal specifically with geometry. The postulates stated by Euclid evolved from the concept of point, line, and surface. Euclid stated 5 postulates. Let's try to understand each of these. The first postulate states that, given two distinct points, there is a unique line that passes through them. To understand this postulate, let's start with 2 points. Let's try to find out how many lines can be drawn through the points. Oh, we can observe that an infinite number of lines can be drawn through the points. Then, which line is Euclid referring to? He is referring to the straight line passing through the points. The straight line is the shortest line that connects the 2 points. This means that any 2 points can be connected with a unique straight line. The second postulate states that a terminated line can be produced indefinitely. For a terminated line, there are 2 endpoints. In other words, a terminated line in present-day terminology is called a line segment. Let's try to understand this postulate using the idea of a line segment. A line segment is a part of an infinite straight line. If we observe the reverse, a line segment can be extended on both the sides to form a straight line. The third postulate states that it is possible to describe a circle with any center and any distance. The statement can be described in 2 parts: the center and the distance. Here the words center and distance correspond to the center and radius of a circle. This postulate indirectly describes the shape of the circle, where the distance between the center and any point on the circumference of the circle is the radius. Geometrically speaking, this postulate means that you can draw a circle starting with the center at any point on the plane and describe the circle with any radius. The fourth postulate states that all right angles are equal to one another. In order to understand the postulate, we will consider 2 right angles, A and B. Angle A is equal to angle B since both are right angles. Let us arrange the angles in such a way that the orientation of the angles change. You can observe that even after the change in orientation, angle A is equal to angle B. Let us try to visualize the fifth postulate. This postulate is also called the parallel postulate. Consider 2 parallel lines. You know that they will never meet or intersect. 2 lines that are not parallel will intersect at some point. Here, Euclid describes an important property that helps verify whether 2 lines are parallel or not. It is done with the help of a transversal line intersecting the lines. If the sum of the interior angle is less than 180 degrees, then the lines are not parallel to each other. To verify this, if we produce the lines further, these will intersect at one point and form a triangle. This is the reason why the sum of the interior angles of the lines is less than 180 degrees. Now, we will recap what we just discussed in Euclid's own words. If a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on the side on which the sum of the angles is less than 2 right angles. From the postulates, we can understand that Euclid stated these postulates as patterns observed among the geometric constructions. Postulate 3 introduces us to the concept of circles, while Postulate 5 gives us the condition to check whether 2 lines are parallel or not. Now, let's discuss some notions. These notions are called axioms. An axiom is understood as it is and does not require any proof. However, we will try to understand these axioms through examples. Remember that these axioms are not restricted to geometry. They are valid for basic arithmetic operations, including addition and subtraction. The first axiom is stated as, things which are equal to the same thing are also equal to one another. Let's try to understand this axiom. Let A and X be 2 line segments with equal lengths. Let B be another line segment whose length is also equal to X. This implies that the lengths of the line segments A and B are equal since both are equal to the same line segment. If we consider a, b, and x as numbers, this axiom corresponds to the transitive property. The second axiom states that if equals are added to equals, then the wholes are equal. Let us take two lines A and B which are equal in length. When A and B are added separately to another line segment x, the resulting lengths A plus x and B plus x are equal in length since the line segments A and B are equal. The third axiom is about subtraction. If equals are subtracted from equals, then the remainders are equal. Let the line segments A and B be equal in length. Let x be any other line segment. If we remove the length of A from the length of x, we get x minus A. Next, let's remove the length of B from x. What we get as a result is x minus b. On comparing the lengths of x minus a and x minus b, we can observe that they are equal. Hence, we can conclude that since the line segments a and b are equal in length, the lengths of x minus a and x minus b are also equal. The fourth axiom states that things which coincide with one another are equal to one another. Let us consider two lines, A and B, which are equal in length. When they coincide, they form a new line which is equivalent to the length of line A or B. The fifth axiom states that the whole is greater than the part. This statement is about the comparison of two objects or quantities. Let's try to understand this statement with an example. Consider the line segment. Let us split this line segment into two parts. Now you can observe that the length of any split part is less than the length of the whole line segment. Or in other words, we can say that the length of the line segment is greater than the length of its split parts. Now, let us have a look at the sixth axiom. It states that things which are double of the same things are equal to one another. Let A and B be two line segments with the same length. When the line A is doubled, the length of the new line will be equivalent to the line segment B doubled. Now, let us take up the seventh axiom, which can be considered as the converse of the sixth axiom. Things which are halves of the same things are equal to one another. Let A and B be two line segments with the same length. When the line A is halved, the length of the new line will be equivalent to the line segment B halved.